Good morning. We are getting ready to go over the test review for Chapter 3, Part 2. This is actually our District Unit 2 test. Let's go ahead and get started. Number 1, write an equation of a line that has a slope of 2 and a y-intercept of -2. All right, so they gave us an m and they gave us a b, and all we have to do is plug those two items into our slope-intercept formula. So y equals 2x minus 2. All right, number 2 says write an equation of a line that passes through this point. So they give us an x value and a y value, and it has a slope of 3. All we're going to do is put that in point slope form. So y minus -5, that's going to change to a plus 5, equals 3 parentheses x minus 2. Okay, so that's our answer in slope-intercept form. I'm sorry, in point slope form. And we're going to take 2 steps to change it into slope-intercept form. The first step we're going to do is we are going to distribute that slope. So I'm going to multiply everything on the right side by 3, and I will end up with y plus 5 equals 3x minus 6. The next step is to isolate y. So subtract 5 on both sides of the equation. Here it cancels, here it combines, and we end up with y equals 3x minus 11. All right, let's try that again. Remember to put something in point slope form. You're just replacing a y value, a slope, and an x value. So again, I've got an x value and a y value, and they gave me a slope of 1/2. So I'm just going to rewrite that. So y plus 3 equals 1/2 parentheses x plus 2. All right, then I want to change it to slope-intercept form. So I'm going to do 2 steps. Step 1, distribute. Shoop, shoop. Y plus 3 equals 1/2 x plus 1. Then you want to isolate y. So in this case, it means subtracting. Here, 3 cancels, and here it combines. So y equals 1/2 x minus 2. That's it. That's your answer in slope-intercept form. All right, number 4, I don't want to do the whole problem, but you would do point slope form, and they gave you an x value and they gave you a y value. What I do want to talk about is I want to talk about the slope. So we need a line that is perpendicular to this line and a line that is also parallel to this line. So our original slope right here, m, is -1/3. A parallel slope would also be -1/3. And a perpendicular slope would have to be an opposite reciprocal of -1/3. So it has to be positive, and it has to be flipped over that fraction bar, or we would just write 3, okay? So you would do the whole point slope to slope intercept process for the perpendicular line and the parallel line with the point given. On number 5, it says, given the 2 points, find the following. So the very first thing it asks us for is the slope. And so given these 2 points, which have x values and y values, we use the slope formula. So slope equals y minus y over x minus x. I went ahead and plugged in my y values and then my x values, and I ended up at -16 over -5. Now that's not quite as simplified as it needs to be. Those negatives cancel each other out. So our slope is actually going to be 16 over 5. A parallel slope would be the same, so 16 over 5. And a perpendicular slope is the opposite reciprocal. So opposite sign, if this is positive, then this has to be negative. And the reciprocal has to be those two numbers flipped over the fraction bar, so 5 over 16. All right, number 6 asks you to graph this equation. This equation is in standard form, so you're going to have to change it to slope-intercept form first. So the first thing I'm going to do is move that 3x to the other side of the equation. So now I have 4y equals -3x minus 8, and then divide everything by 4 to get y alone. So now I have y equals -3/4 x minus 2. Okay, so my y-intercept is 2. I'm going to go ahead and put a dot right there. And my slope is -3 over 4. So to find the next dot, I'm going to go down 3 and 4 to the right. Okay, now I kind of ran out of room on this graph, so I'm going to go backwards. I'm going to go up 3 and 4 to the left. And that should be enough points to graph that line. So connect those dots, and that is your line. Okay, number 7, they give you 2 lines, and they give you 2 points on each of those lines. So what you're expected to do is find the slope. Again, you're going to use this formula. The slope equals y minus y over x minus x. And what you're going to decide is which one is steeper. Steeper is going to mean the line whose slope has the greater absolute value. So you're really just looking for the bigger number, regardless of whether the slope is positive or negative. Let's check out number 8. In number 8, it says that KL, so this line right here, is parallel to JM, so the two horizontal lines are parallel. It also says that JK and ML are parallel. I went ahead and marked them parallel so that I could remember what was parallel to what on this problem. Now, the first angle value that they ask us for is KLJ. So follow that around like it's a map, K to L to J. That's this angle right here. Now, what I did to make it a little easier is I redrew just the important lines. And you can see that I have 2 parallel lines in a transversal, and that the angle that I'm looking for actually is alternate interior with this 20 right here. So this measure is 20 degrees. All right, now the next one that they want us to find is KJM. So from here to here to here. So I redrew that one as well. And what you can see is that KJM, this angle right here, is alternate, or sorry, not alternate, it's consecutive interior with this 125. So in order to find that angle, it's 180 minus 125 because consecutive interior angles are supplementary. So you have 55 degrees for that angle KJM. Lastly, they asked us to find angle JLM. Now, angle JLM goes from here to there and then there. So there are just so many lines on this picture that it's kind of confusing, and I redrew it, but I still think I have maybe a few too many angles. It's really just this angle here and this angle here. Now, we don't actually have enough information to figure this out, but we did find that the total of this angle, right, KJM, was 55. So from here all the way to here, it was 55 degrees, right? So if I just wanted to find this part right here without the 20, 55 minus 20 is going to give me 35 degrees. And that happens to be alternate interior with this angle right here that they're looking for, JLM. So that one is 35 degrees. Okay, number 9 and 10 ask you about finding a value of x so that A is parallel to B. So to prove that lines are parallel, you have to prove the converse of those angle relationship theorems, right? Before we knew that the lines were parallel and therefore the angles had certain relationships. So on number 9, these are alternate interior angles if these lines are parallel. So to prove that they're parallel, we would be using the converse of the alternate interior angles theorem. And so what we need to do is solve for x so that if x is a certain number, then A will be parallel to B. So with alternate interior angles, if those angles are congruent, then you can prove that the lines are parallel. So 145 equals 5x. And then you just divide both sides by 5. 145 divided by 5 is 29. Now, if x is exactly 29, then A is parallel to B. If x is anything more or anything less, then these two angles are no longer congruent and those lines are no longer parallel. Okay, next, number 10, you have these two angles that happen to have the relationship of being consecutive interior angles. So they're not the same angle, but they are supplementary. So in order to solve this one, you would set it up where 72 plus 3x plus 15 equals 180. Once you have that equation written, then you would solve for x, And that is the number that x has to be if you need to prove that line A and line B are parallel. Number 11 basically asks you what all of the angle measures have to be if lines A and B in this drawing are to be proved to be parallel. The angles that are corresponding and alternate exterior, consecutive interior, all have to match up. So basically, at both intersections, all of those angles have to be the same if you're going to prove that that line A and line B are parallel.